Today we're going to talk about how exponential functions show up in the real world. Exponential functions are very, very common in finance and other places where we're talking about money. They are kind of how they base the amount of money you have to pay back on a loan, as well as interest rates in banks. Now, we are used to using an exponential formula that looks something like this. F of x is equal to a times b to the x plus c. While that's an easy formula for graphing, that isn't necessarily the formula we use when we're talking about finance. The formula we use looks something like this. The amount of money is equal to P times 1 plus R to the T. Now, we've introduced a few different letters here, but we'll talk about what they mean really quick. P is the principal. Another word for principal is the amount borrowed. Or the amount that you start with. T is time, most often measured in years, but it can be measured in something else if you need to, like months or days. And then R is the rate of the interest. You'll often see interest rates written as percents, but we use them as decimals in this formula. Quick refresher, if you've got a percent, say for example 5%, that's the same thing as 5 divided by 100. Percent literally means divided by 100, or 0.05. Be careful with your percents. This is probably the most common place where I see students going wrong in these kinds of problems. It's messing up the percentages. All right, from here, let's go ahead and try a few sample problems. We'll skip 1 and 2 for now, and let's just jump straight to number 3. You buy a house for $250,000. You choose not to pay anything up front and finance the whole amount. The interest rate is 4.5%. If the length of the mortgage is 30 years, how much will you pay for the house? So let's go back and dissect this problem. We paid $250,000 for the house. That is our principal amount. Our interest rate is 4.5%. Now that's the same thing as 4.5 divided by 100, or 0.045. So we'll introduce that with adding 1. Now let's talk about the length of how long we're going to take out the loan. That is 30 years, so we're going to have our exponent be 30. Notice t is the exponent in this case. From here, you're going to have to type it into a calculator. Once you do so, you'll find out that we end up paying on this house $936,329.53. Meaning, you almost buy the house 4 times before you actually own it. And you have to pay back almost $1 million on the house. It's not the best investment you can make. Part of why is because you're not putting anything as a down payment. Let's go ahead and try number 1 as well. Suppose one of your ancestors invested $500 in 1800 and in an account paying 4% interest compounded annually. Okay, so here we have our principal amount is 500, and our interest rate, R, is going to be 0.04. Now I just took 4 and divided it by 100 again. So let's go ahead and plug that into our formula. Our principal amount is 500 plus 1.04. Now, this happened in the year 1800, and we want to know the balance in the year 1850. How many years elapsed in between 1800 and 1850? 50 years. So in this case, our time, the amount of time spent, is 50 Plug that into a calculator, and you'll get, I believe it's about 3,553 and some odd cents. I don't remember. I don't have the exact number on me. All right. So now let's go ahead and let's take a look at a few problems on the back. For example, specifically number 8. A new truck that sells for $42,000 depreciates 12% each year. Write a function that values the model of the truck. The model's the value of the truck. Find the value of the truck after 7 years. So notice we have a certain word here, and that word is depreciates. Come on, let me draw on this. There we go. This word depreciates. Depreciates means that the amount that it's worth goes down. Which is true. The second you drive a new car off the lot, it's no longer a new car. It suddenly becomes a used car, which means it's worth a whole lot less money. So what is our interest rate in this case? Since it's going down, we lose 12% each year. So we have a negative interest rate because the price is going down. So we can turn that into a decimal. That'd be 12 over 100, which would be 0.12. And we can plug that in for our interest rate. Make sure it's negative. So that would be 42,000 times 1 minus 0.12 to 7 years. From there, you can simply type it into a calculator to get your answer. As always, let me know if you have additional questions.